Okay, assalamualaikum and hello everyone. So we are going to go into chapter 2, Thermochemistry, and there are 1, 2, 3, 4 subtopics in this chapter. Okay, so the first subtopic is Concept of Enthalpy, and these are your learning objectives. So firstly, you need to know how to explain endothermic and exothermic reactions using energy profile diagrams. Okay, recall that from the last chapter. And then state standard conditions of reaction and define the following terms. You have enthalpy and standard enthalpy. So what does it mean by standard? Next, you need to know how to define and write thermochemical equations. This is very, very important. Okay, so you have a few change in enthalpies that you need to know. We have formation, combustion, neutralization, hydration, dissolution, or solution. Okay, same thing. All right, thermochemistry. So what is thermochemistry? You've heard of thermometer, right? So thermo basically means temperature or your heat change, okay, in chemistry, in chemical reaction. So it is how your heat flows in a chemical reaction. So we're going to study heat change in our system, okay. So right here we have a typical chemical reaction from reactants to products, all right. So your reactants to product is basically your system, okay. So there are a few important terms in thermochemistry that you need to know. Firstly, it is heat. So heat is basically the energy transferred between two bodies at different temperatures, all right. So our other cold region and hot region, okay. Your heat travels from cold to hot, right. And then we have system. So system is any specific part of the universe that we wish to observe on its changes. So system is basically what we will focus on lah. So in our case, our chemical reaction will be our system, okay. Surrounding pula will be what is outside. So if this is your system, so surrounding is basically whatever that is outside of your system, okay. So it is everything that lies outside of your system, okay. So we have system inside and surrounding outside, all right. Okay, so how does heat flow? Like I said before, our heat flows from a hotter body to a colder one. So basically when we have like 80 degrees Celsius room, and then we have an air conditioned room like 17 degrees Celsius contohnya, your hot air will flow into the colder region, okay, colder room. So when there is a temperature difference between a system and its surrounding, okay, heat will be transferred from a region of higher temperature to one of lower temperature. Once the temperature becomes equal, heat flow stops. So it reaches a balance lah, an equilibrium in temperature. So here, right here, is it endothermic reaction or exothermic reaction? So for the first one, we have a cup of tea, okay, a hot cup of tea, like 50 degrees Celsius, all right. And then this will be your system, okay, this will be your system, and the surrounding will be your room temperature with 25 degrees Celsius. So what will happen here is that heat from this tea, this hot tea, will flow from the system to the surrounding. So heat will be released. That means that this one here, this one is an exothermic reaction where your heat is released, all right. Okay, so as for this one, we have an ice cream. So ice cream will be cold, right. The surrounding is your room temperature, so the ice cream is the system. So what will happen is that your ice cream, what will it do? It will melt, right. So it will melt in room temperature. So that means what made it melt? Because heat from your surrounding is absorbed by your system, okay. The ice cream, it absorbed heat, that's why it melts, okay. So this one is an endothermic reaction because your system absorbs heat, Okay, so what will happen is that our system here, it will release heat, okay, or absorb heat, okay, until the temperature of the system and the surrounding is equal, and then your heat flow will stop. Okay, we have a few types of systems. Okay, so firstly we have an open system. So open system is a system that can exchange mass and energy with its surroundings. Okay, so for example, we have here our cup of coffee. Okay, so it is not isolated. Okay, it is in the open. Alright, therefore yang kat luar ni is your surrounding. Okay, and this will be your system. If you drink or you remove your coffee, then you can exchange mass, maksudnya energy. This will be, we will be focusing on heat energy lah. Okay, so in this case, this coffee, okay, if it's hot, it will release heat energy to the surrounding. Okay, so this is an open system, it's not isolated. Awak boleh exchange mass and energy between the system and its surrounding. Okay, so a closed system pula, closed system is a system that allows the exchange of energy only with its surrounding. Okay, so there is no exchange in mass macam in open system. So let's say we have a teapot here. Okay, so this teapot is closed, right? So we have hot tea in there, and we close the teapot. Okay, let's say ini pun close juga. So in this case, okay, your heat energy can still be transferred, okay, out to the surrounding from your system. Okay, but the mass, let's say the tea inside here, it is not being exchanged, alright, because we closed our teapot. Okay, so this is a closed system. Isolated system is a system that does not allow the exchange of their mass or energy with its surrounding. So here we have our same teapot here with tea inside, alright, it's closed, alright, so your teapot, but it is isolated in a container. Okay, so it is isolated. We do not have any exchange in mass. Okay, no tea is being spilled up, nor energy. Okay, so your heat, it does not escape from this isolated system, okay, to your surrounding. So let's say this one here, out here, this is your surrounding. Okay, so there's no exchange in energy as well for isolated system. Okay, all right, those are your three types of systems. And now we're going to look at the two types of chemical reactions that we have. You have learned this from the last chapter. So we have endothermic reaction and we have exothermic reaction. Okay, so endothermic reaction is a process that absorbs energy from the surrounding to the system. Your delta H is a positive value. Alright, for exothermic reaction, it is a process that releases energy from the system to the surrounding. So basically your system will release heat energy. So when this reaction happens, okay, let's say ni pasal awak dah tambah whatever other substance, so this reaction in here, if you touch this container, this beaker, it will feel hot. Okay, maksudnya it is an exothermic reaction. Okay, for this reaction, the delta H is a negative value. Negative value denoting that heat is released. Okay, positive value denoting that heat is absorbed in this reaction. Okay, we need to know how to draw the energy profile diagram for each of the reactions. So for endothermic reaction, okay, like before, we need to have our enthalpy or energy for the y-axis and reaction coordinate or progress of reaction for the x-axis. Okay, and then our curve will need to have our reactant, our hill, okay, where we have our activated complex or transition state, okay, and then we have our products, okay, and then we need to have our activation energy and also our enthalpy change, okay. These are very important labels you need to have in your energy profile diagram. 1 mole of liquid water, okay, it absorbs heat here with this positive sign. It absorbs 44 kilojoule of heat, to be exact, okay, to form 1 mole of vapor, okay. Your water is in gaseous state, so this is vapor. So in this reaction, we can see that heat is absorbed. So if you draw your energy profile diagram, you know that your enthalpy for your reactant will be smaller than the enthalpy of your product, okay. So your product is up here and your reactant is down here, okay. So when you draw the line for enthalpy change, your arrow from reactant to product, it will be from down here upwards, okay. So this means energy is being absorbed for this reaction to happen, okay. Alright, so we have our activation energy macam biasalah, okay. So that's how you draw. Next we have exothermic reaction. So for exothermic reaction, it will be the opposite, where your enthalpy for your reactant will be higher than the enthalpy for your product. Your enthalpy of product is down here and your reactant is up here. So when you draw, okay, when you draw the arrow for enthalpy change from reactant to product, it will be downwards. This denotes that energy is released. So you have your negative sign here, okay. So in this reaction, heat will be released, okay, from the system. So in this system, this chemical reaction is the system. So when this reaction occurs, there is 809 kilojoules per mole of heat being released, okay, for this reaction. Next, we need to know the term enthalpy change, delta H, okay. So enthalpy is basically a thermodynamic quantity. That means the total heat content of a system, alright. So enthalpy change or delta H is the difference between the enthalpies of your products and the enthalpies of your reactants. So HP tolak HR reactants, okay. Then you get delta H. So it can be positive or negative. Macam tadi, we saw endothermic and exothermic reactions. The other definition that you need to know is standard enthalpy. So what does it mean by standard? Okay, standard is denoted by this dot up here. Okay, so ini delta H je enthalpy change, but this is standard enthalpy. Maksudnya delta H not. Alright, standard means that the reaction occurs at standard conditions, which is 298 Kelvin and 1 atm. So these are the standard states, so you need to take note of this lah, okay. Okay, so thermochemical equation is basically a normal balance equation, alright, but you must have the enthalpy change, which is your delta H. So your thermochemical equation has to have two important things, which are your phases for your products and reactants, and also delta H, where you have to look at your sign and magnitude, make sure that it's correct. Okay, so how do we write thermochemical equation? Okay, how does it look like? It will look like this, where you have your reactants and then products and also your enthalpy change. So in this reaction, for this reaction where methane reacts with 2 moles of oxygen gas, you will get 1 mole of carbon dioxide gas and 2 moles of liquid water. Okay, so in this reaction, it is an exothermic reaction where this reaction will release 890 kilojoule per mole of heat. For the second one, okay, if you notice, this reaction is the reversed reaction of this one, okay. So this is the original one, and then it is reversed, okay. So this is reversed. So what will happen, okay, what will happen to the enthalpy change? The enthalpy change will have a change in your sign. Okay, so this one is negative where it is exothermic. So when the reaction is reversed, you will get an endothermic reaction, but with the same magnitude. All right, for enthalpy change. So the magnitude remains the same because the number of moles for your reactants, okay, that is now product is the same. Okay, for this one as well, it is still the same, no change. So it is only the change in sign. But for this one, okay, comes from the first thermochemical equation. But if you notice, the whole equation has been multiplied by 2. The stoichiometric coefficient is times 2. So here you have 1 mole, this is 2 moles, 2, 4, 1, 2, 2, 4. Okay, so your enthalpy change, okay, will not have a change in sign, but the magnitude will be multiplied by 2 as well. Okay, so that's how you get 1780 kilojoule. Okay, the unit is only kilojoule because you will see later that this is actually enthalpy of combustion. Okay, so methane is being burned in oxygen. All right, so for enthalpy of combustion, your 1 mole will refer to your substance that is burned. So in this case, you have 2 moles of methane, so it is not per mole of your substance. So this one you don't put any per mole because this is 2 moles. All right, now we're going to look at the types of enthalpy changes that we have. We have heat release. The definition will be heat released when what is the reaction. So we have enthalpy of combustion. This is the symbol delta H with subscript C. Enthalpy of neutralization, it is also an exothermic reaction. Okay, acid base react together and you will get salt and water. And enthalpy of hydration, when you change your substance into aqueous. For heat change, okay, it means that heat change when okay, that means that it can be exothermic or endothermic. Okay, for example, for enthalpy of formation, delta H formation, standard enthalpy of formation, delta H not formation. Okay, enthalpies of solution atau dissolution. Okay, this is the same thing. All right, it is not the opposite. This is the symbol delta H solution. And finally, we have heat absorb. So heat absorb is basically endothermic lah. So the definition will be heat absorb when . Okay, so we have enthalpy of atomization delta H with subscript E. Okay, alright, so let's look at heat released. Alright, so one by one, we have enthalpy of combustion defined as the heat released. Okay, we have negative when 1 mole of substance is completely burned. 1 mole will be referred to the substance that is burned. Okay, burn in excess oxygen at the stated conditions of temperature and pressure. Okay, so basically when you write delta HC combustion, you will know that 1 mole of substance is being burned in oxygen, okay, to produce the product here. So it will be negative because combustion kan, so you are burning something, you will have heat released. Okay, so the per mole here refers to 1 mole of substance that is being burned. Okay, alright, so this is important. Okay, you need to know per mole to 1 mole refers to who, which one of your reactant or product. Alright, next we have enthalpy of neutralization. So neutralization is basically acid and base forming salt and water, right? So enthalpy of neutralization is the heat released, okay, heat released when 1 mole of water is formed from the neutralization of acid and base at the stated conditions. The delta H is negative because heat is released. So basically 56.2 kilojoule is released when 1 mole of water is formed from the neutralization of hydrochloric acid and sodium hydroxide base. Okay, so if you have a strong acid and strong base reacting together, you will get approximately delta H negative 57.3 kilojoule per mole. Okay, if you have weak acid or weak base, then your enthalpy change will be less than 57.3 lah. It will be less than this value, alright, because we have partial dissociation of your acid. Okay, next we have enthalpy of hydration, delta H hydration. That means you are going to form aqueous ions. Okay, so enthalpy of hydration is the heat released when 1 mole of, what does your mole represent? 1 mole of gaseous ions is hydrated in water. Next we have heat change. The first one is enthalpy of formation. Okay, so enthalpy of formation is the heat change. Maksudnya your delta H can be negative or positive. It can be exothermic or endothermic reaction. Okay, heat change when 1 mole of a compound is formed. Okay, from its elements in their stable states under a stated temperature and pressure. This is the enthalpy of formation for 1 mole of liquid water. Okay, so the heat change is negative 286 kilojoule per mole. Okay, please pay attention to how I read this thermochemical equation. The heat change is negative 286 kilojoule per mole. 286 kilojoule of heat is released, okay, because negative, when 1 mole of liquid water is formed from its elements in their stable states. Okay, what does it mean by elements in their stable states? Maksudnya, if you have hydrogen here, you will use hydrogen gas molecule, and since you have oxygen here, you will use oxygen gas molecule. If you have carbon, like in CH4, that means you will be using carbon solid. Okay, and you will be using H2 gas molecule to form 1 mole of CH4. But then you have to balance lah. Okay, balance your chemical equation and make sure you have your delta H, because thermochemical equation kan. Let's see if the standard enthalpy of formation compounds Cl2 and carbon graphite is formed at standard conditions, which is 1 atm and 298 kelvins. So what does it mean when your delta H not formation is 0, is equal to 0? This means that your substance formed is already in its most stable state. Okay, Cl2 memang dah dalam stable state dia. You do not need to do any heat change, okay, when forming Cl2 gas. Alright, same for carbon graphite atau carbon solid. Okay, it's already in its standard state. These are the examples, okay, of elements in their most stable state, so you should take note of this. Alright, okay, next we have enthalpy of solution or dissolution. It is the same thing. Okay, it is the heat change when 1 mole of substance is dissolved in solvent water to form an infinitely dilute solution. Maksudnya ini awak punya aqueous ions ni is already dissolved lah in your water. So this one is the 1 mole. Okay, so your whatever substance that is dissolved in your water is your 1 mole for enthalpy of solution. Okay, so in this case 690 kilojoule of heat is absorbed when 1 mole of substance, okay, is dissolved in solvent water to form infinitely dilute solution. Okay, next we have heat absorbed. There is only one enthalpy change, delta H, which is delta H atomization. Okay, it can also be like this. You can write like that, atomization. So delta H atomization is the heat absorbed. Maksudnya this reaction requires heat to be absorbed when 1 mole of gaseous atoms is formed. Okay, formed maksudnya your product from its element at the stated conditions. Okay, alright, so for this one, meaning when you want to form 1 mole of chlorine atom gas, okay, you will need to form it from your element in its most stable state, macam yang tadi, delta H formation. Okay, for sodium pula, to form sodium gas, okay, atomization of sodium, it will be formed from its stable most stable state will be sodium solid. Okay, so for enthalpy of atomization, why does it need to be heat absorbed? Why do we need to absorb heat? Because, okay, in this case, okay, you have your chlorine gas molecules, kan, Cl. You need to absorb heat to break this bond to form 1 Cl gas atom. Okay, alright, so 1 mole will refer to the gaseous atoms that is formed. Okay, so in this case, it is from solid to gas. It is already 1 mole of atom, okay, but your sodium atom is its most stable state is in solid phase. Okay, so what you're going to do is you're going to break the intermolecular force in your sodium solid lah, so you will get it in gaseous phase. Okay, you get your 1 mole of gaseous sodium atom. Okay, so ingatlah atomization is heat absorbed. Okay, dia memang positif. Alright, so 1 mole refers to the 1 mole of gaseous atom that is formed, right, from its elements at their most stable states. Alright, so the rest of this, I would like you to read it by yourself. Okay, basically, actually, I have already written down the definitions for you, and you should look at them one by one. So for this example, it already has its answer, so I want you to try to do it by yourself first before looking at the answers. Okay, so this is the end of 2.1 concept of enthalpy, which is very important. You need to know how to write your thermochemical equation. Okay, in order to do that, you need to understand the definition of all the enthalpy changes that you have. There are 5. Okay, and you also need to know how to draw your energy profile diagram for exothermic reaction and endothermic reaction. Okay, alright, that's all. Thank you.